Hello, everyone. Welcome to our lesson from smarth.education. Right, we're going to look at angles in the same segment. Kindly subscribe to our channel. Right, let's continue with our lesson. Right, an arc or chord. An arc or chord. You know what an arc is, you know what a chord is. So, an arc or chord of a circle subtends equal angles at the circumference of the circle. An arc or chord of a circle subtends equal angles at the circumference of the circle. So like now I have this arc here, arc PQ or chord PQ. You see that? So this arc PQ or chord PQ. Okay, these are two different things, isn't it? There is an arc, there is a chord. Chord is a straight line, the dotted line, right? So these subtend this angle S there by the circumference. So we're saying this angle is equal to this angle, which is also subtended by the same arc and the same chord by the circumference. So angle S is equal to angle R. So an arc or chord of a circle subtends equal angles at the circumference of the circle. Okay, remember that. And then the reason we write, we say angles in the same segment. Angles in the same segment. Right, if I can show you what the chord does, the chord divides a circle into two segments. Let's say this is chord AB. So it divides the circle into two segments. This will be the minor segment because it is smaller, and then this one will be the major segment. It is bigger. So the angles, we're saying these are the angles in the same segment. Let's say this angle here and this angle here are what? Are angles in the same segment, even this one. It will be the angles in the same segment. You see that? They are all in the major segment. Even if you can come this side to the minor segment, you can have different angles subtended here in the same segment. This angle, even this one here, they are in the same segment with these ones. Okay, so we have two different segments here. Let me just divide them using the color. So this one here, this angle here, okay. Let me name them so that you don't get confused. Okay, so this angle, let's call it C and D, will be equal because they are angles in the same segment. C and D will be equal because they are angles in the same segment. And then A, B, C, D, E, F, G are equal. E, F, G are equal because they are also in the same segment. You see that? Okay, right. Now, we want to prove that angle P is equal to angle Q and angle R is equal to angle S. Let's start with angle R and S. So we have our do our construction, which is PO and QO, and then we can say this angle at the center. So angle what? POQ is equal to 2 times angle S. You see that? It's 2 times angle S. It means it's 2 times this angle here. Okay? And then at the same time, before we go there, what is the reason? Why are we saying angle POQ is 2 times angle S? Because it's angle at center equals 2 times angle at circumference. Okay, you see that? And then again, angle POQ is equals to 2 times angle R. So POQ is equal to 2 times angle R. Okay, 2 times angle R again, right? Why? Because this angle at center equals 2 times angle at circumference. Okay, right. Now, we are saying this angle 2 times angle R is equal to P angle POQ, and 2 times angle S is equal to angle POQ. So these two things are equal to the same thing. What do I mean by that? Let me say, for example, saying X is equal to 2 and then Y is equal to 2. What does that mean? If X is equal to 2 and Y is equal to 2, then X is equal to Y. So we are saying now, if 2 times angle S is equals to POQ, angle POQ, and 2 times angle R is equal to angle POQ, therefore angle S is equal to angle R. We've proved that. Okay? Right. So we can what? We have proved that angle R is equals to angle S. Now, we can do the same thing. Similarly, we can do the same thing for angle P and Q. So we can have our SO there and RO. And then we can see this angle here is equal to 2 times angle P. So we can say angle SOR is equal to 2 times angle P. Why? Angle at center equals 2 times angle at circumference. Okay? And then again, we can say angle SOR is equal to angle Q. Is equal to 2 times angle Q. Angle SOR is equal to 2 times angle Q. Okay, why? Angle at center equals 2 times angle at circumference. You see that? So now we can say this angle is equal to this is equal to this. So therefore, angle P is equal to angle Q. You see that? Okay. And then the converse of this theorem. If a line segment joining 2 points subtends equal angles at 2 other points on the same side of the line segment, these 4 points are concyclic, meaning that they lie on the circumference. So we're saying that if this angle is equal to this angle, they are on the same side of the line segment, then these 4 points are concyclic. So meaning that P, Q, R, S are concyclic. Do you see that? That's the converse theorem. Okay, and then the reason we write, we say line subtends equal angles. Line subtends equal angles, or say converse of angles in the same segment. Okay, right, let's do this activity, then we'll be done. Given a circle with points A, B, C, and D on the circumference, calculate the value of X and Y. So now we can see that we have our chord here, BC, which subtends this angle A and this angle D. So we can say here, angle A is equal to angle D. What is the reason? Angles in the same segment. Okay, angles in the same segment. So therefore, X is equals to 25 degrees. Done. Okay, so when we want to find Y, we can do the same thing with our chord, the 80, which subtends this angle and this angle. So we can say that angle B is equal to angle C. Why? These are angles in the same segment. Okay, and then therefore, Y is equals to 15 degrees. Done. Okay, right. I really hope you learned something from this lesson. We're going to continue with angles in the same segment. I'm going to bring more questions in the next lesson. Okay, let's meet in our next lesson.